So we're talking about solid geometry in this lesson, and we're going to classify and identify three-dimensional figures from a net. This is 11.1b. So we have one previous video for this lesson that is linked in the description along with the geometry playlist if you need it. We can classify and identify three-dimensional figures by naming all of their vertices, edges, and bases. Here we have a rectangular pyramid, and its vertices are A, B, C, D, and E up here. Its edges are segment AB, segment BC, segment CD, segment DA, and then we have the edges that are AE going up to the apex, BE, CE, and DE. The base is a rectangle, ABCD, so this is a rectangular pyramid. Here we have a cylinder. There are no vertices and there are no edges. Edges have to be straight. These are curved. So our bases are circle P and circle Q. It's a cylinder. A geometry net is a two-dimensional diagram of all the surfaces of a three-dimensional figure or solid. It can be cut out, folded along the edges, taped or glued together to form a model of the 3D figure or solid. So this is the net of a cube. It's got 6 faces. We could see that would be the top or the bottom, and then these would be the 4 sides. To identify a three-dimensional figure from a net, we look at the number of faces and the shape of each face. So in this first one, we've got a rectangle, a rectangle, a rectangle. There's 2 triangles. There's 2 congruent triangular faces, and the remaining faces are parallelograms. Now look at this one. We have 2 congruent triangular faces, and the rest are parallelograms. And look here. We have 2 congruent triangular faces, and we've got squares. Well, these nets basically fit the same description. When folded, they're going to form triangular prisms. So that would be one. And if you look at this parallelogram right here, it's a little fatter than this one. So this would be a little bit fatter than this one, wouldn't it? These parallelograms are thinner. And then these are square. It would still make a triangular prism, but then each face would be a square. But they're all triangular prisms. And a 3D figure, a three-dimensional figure, may have several different nets. Here we've got 5, 10, 11. There's 11 different nets will form 11 identical cubes. They all have 6 squares, and if we folded them, they would all be the same identical cube. So a 3D figure can have many different looking nets. This net has 6 square faces. It forms a cube. If we were to fold it on the dotted lines, we could tape it together to make it look like this cube. And this net has 6 rectangular faces. It forms a rectangular prism, or we could call it a cuboid, couldn't we? If we folded it on the dotted lines, it would form this shape. This net has 4 triangular faces, and it forms a triangular pyramid. We can see the face here is a triangle. That's what it would be sitting on, and we could use it as a base. We fold up these 3 other faces to an apex, tape it together, and we'll make a triangular pyramid. And both of these nets have 1 square face with 4 triangular faces. They form square pyramids. We could fold them right here along these edges and tape them together. We could fold this one along the edges, tape it together, and we'll have a square pyramid. Both of these nets have 1 pentagonal face. See that? Here's a pentagon, and it's got 5 triangular faces. This has got a pentagon face and 5 triangular faces. And they'll form pentagonal pyramids. Different looking nets, but they'll make the same type of figure. This net has one circular surface and a curved surface. If we curved this edge to this edge and taped it together here and folded this up, it would form a cone. This net has two circular surfaces and a rectangular surface. This would form a cylinder. We could take this edge here and curve it around and tape it to this edge, and then fold this up and fold this up, and it would form a cylinder. So you can find these on the internet and print them out, and you can cut them out and get some tape, and you can make some 3D shapes just by folding them on the dotted line. See, we have a square pyramid. Here we have a cube. We can just fold these up, see, and make a cube. Here we have a rectangular prism. We can just fold up the sides, fold this over, see? So many of you probably learned what is in this lesson from an earlier grade, but I want everyone to be on the same page as we keep moving forward before we talk about volume, okay? And we're going to talk about surface area, I believe. So our next part of this lesson, 11.1, is 11.1c, and we're going to talk about cross sections of three-dimensional figures. Then we're going to move on to 11.2, which is broken into three parts, A, B, and C, and we're going to talk about the volume of prisms, the volume of cylinders, and the volume of composite figures. I actually found some pretty difficult looking nets when I was browsing images on the internet for them, and if you could put them together, that would be pretty cool. So I hope you understand now how to classify and identify these from a net. You can look at their surfaces, their faces, their edges. And I hope you have a great day, and I'll see you next time. Bye.